Good evening, my dear NEET warriors. And finally, I know you guys were waiting for this session on Monday, but I had to shift it because of some UPS issues. And finally, we are here. And the NEET Zero session on YouTube. Yep. After an amazing kickstart for NEET Station 1, which was just done some time back. In case you have missed that video, please do check it out. It's there on the channel itself. And today we're going to do basic maths, of course. So if you are not aware of what station 1, wow, this is station 0. What is station 1? Well, just check it out on the channel itself. It is there in the live section. You can see NEET 2025 restart hope is coming. Okay, that's the next plan for NEET 2025 station 1. So let's get started with station 0 today. And those of you who do not know me, my name is Shreyas. I have been teaching, a lot of students, thousands of students mentored and already successfully selected in the top-notch colleges in the country. And I love teaching. I love physics. I scored almost full marks in my JEE advanced paper when I wrote it. And yep, I did my research from IIT, did my graduation from IIT Nagpur, and already taking care of so many channels out here. And love you all that you guys show utmost love, sincerity, and that hope in all of us. Thank you so much, guys. So I'm pretty sure you're all excited and all ready to kickstart the session. Hi, Chandan, Medico, Disha, Ram. Welcome, Desati, Krishna, Strusti, Ashwini, sir. Will I continue this series? This series will take a new turn on YouTube and you will stay tuned for that. Don't worry, because we have to make sure that we do as much as possible, and there will be many things that will be happening. So you will see that. What is the plan? Yep. So let's begin. And if you have any doubts regarding, sir, when will that happen? When will this happen? Please leave a comment. I will be happy to help you out. Number one. Number two, make sure throughout the session you play along with me. I'm going to teach you very basic, from basics and from the foundation level, and build up the concepts for your NEET. Okay. So today we are going to do quadratic equations. Okay. 1 second. Oh my God. What just happened? Can I just undo? Okay, thank God. Okay. Yeah, today we are going to do quadratic equations. We're going to do binomial approximation. We are going to do series and summation, slopes and derivatives, that is the calculus, areas and integration. Now these are the most important things when you talk about basic maths for physics, and one of the most foundational topics, because you will need it in vectors, in kinematics, Newton's laws, rotation, electromagnetism. You name any most of the chapters will need one or more of these concepts. Okay, so let's begin. The questions are going to start very soon, Saran. Let me tell you that question series is starting on YouTube very soon. So stay tuned for that. Let's start with the first concept of quadratic equations. Yep. Let's start with the first concept of quadratic equations. Now quadratic, this term actually means the power is 2, the number 2. The power of the equation is 2. I will tell you what is a quadratic equation and what is not a quadratic equation. Things which are a quadratic equation are y is equal to x square plus 3x plus 5. It is a quadratic equation. Y is equal to 4x square minus 2x minus 7 is a quadratic equation. Y is equal to 3x square minus 2. That is also a quadratic equation. Y is equal to x square minus or plus, let's say, 4x. That is also a quadratic equation. S is equal to ut plus half at square is also quadratic equation in time. Instead of x there is time, instead of y there is s, and there could be so many more examples. You can see the power, highest power is basically 2. Actually not power, the highest power of that equation is basically the number 2. All of them have highest power as the number 2. Are you able to see that? Even more equations I can put. U, let's say for example, u is equal to some number plus half k x square. Everywhere the highest power is 2. all these are basically quadratic equations. Which ones are not quadratic equations? Let's have a look at that. Y is equal to 3x is not a quadratic equation. Y is equal to 5x plus 2 is not a quadratic equation. Y is equal to x cube minus 2 is not a quadratic equation. Y is equal to, let's say, sine of x is not a quadratic equation. Y is equal to 1 by x is not a quadratic equation. Y is equal to 1 by x square plus 2. Although the power is 2, it is in the denominator, so it is not a quadratic equation. All these things are not a quadratic equation. Is the difference clear? Give me a thumbs up. Yep. Yes. In fact, Thanesh, I have planned the NEET Express Station 1 so that the droppers, sorry, partial droppers and the 12th standard students will be able to attend the classes live, because that was one major concern. Sir, the classes are in the afternoon, how can I attend? My class 12th is going on. So we have kept that in mind. Number one. Number two, we have also kept in mind 12th standard portions will be completed first. Okay, priority wise. I'm so glad Shri Krishna means a lot. Okay, now whenever you get such equations, you will have to solve it, because what is physics? What is maths? Solve, 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 find x, find that, find this. That is what happens. So you have to solve it, find this, find that. So when you solve a quadratic equation, here is an interesting thing that happens. See, I will give you an example. When you write y is equal to 4x minus 8. Y is equal to 4x minus 8. This is not a quadratic equation. In fact, it is a linear equation. Reason is the highest power of x is 1. The highest power of x is 1. That's why linear. So the highest power is 1. Now you will hear this word. What is the root or the solution? What is the root or the solution? The meaning of the word root or the solution of the equation, of that particular equation, is when is this y going to be 0? When is this whole expression going to become 0? Because this is linear equation, y being 4x, y is 4x minus 8, that is 0. Therefore, 4x is equal to 8. Therefore, x is 8 by 4, that is 2. So, x is equal to 2 is a root of y is equal to 4x minus 8, which is a linear equation. And there is only one root for this. There is only one solution, one value of x which will make this guy 0. And there is a reason for that. You know what is the reason? If I draw the graph of y is 4x minus 8, it becomes very interesting. Look at this, my dear students. Look at this. Y is equal to 4x minus 8. If I draw this, do you see the graph is a straight line? And where is the y coordinate becoming 0? It is becoming 0 at x equals to 2. So that is the solution, where it intersects the x-axis. Where it intersects the x-axis becomes the solution. So this is x equals to 2 is the point, is the solution. That means it intersects the x-axis at x equals to 2. The graph will intersect the x-axis at x equals to 2. I hope this is understood and it is very easily seen. You can choose some other equation also, like say for example 6, or instead of 4x you can make it 5x. All these are straight line equations. They will intersect at different places. But a very interesting thing happens the moment I do not keep a linear equation, I keep a quadratic equation. Let's say for example y is equal to, say for example, x square minus x square minus 5x plus 6. Now this is definitely a quadratic equation. Best part, it is not a straight line graph. It is not a straight line graph. In fact, if you draw the graph of such a thing, you will see it is a curve, and that curve is a parabola. Don't believe me? Let's see it. X square minus 5x plus 6. Y is equal to x square minus 5x plus 6. Look at it. It's a curve, and this shape is called as a parabola. Best part, it is intersecting, cutting through the x-axis here 2 times. So there are 2 answers or 2 values which will satisfy that particular equation. 2 values. Exactly, there are 2 values. So such a thing, the graph we just saw, it was like this. So it will hit over here and here, and we saw that it cuts at 2 and number 3. We'll come to that, how to find these numbers, the number 2 and 3. So x equals to 2 and 3 are the roots, or basically the solution to the quadratic equation. The graph, which is a parabola, intersects the x-axis twice, suggesting that there are 2 roots, to this particular equation. Is this clear? So quadratic equation in general will have usually up to 2 roots. You will be like, sir, why are you saying in general, sir? I thought always they will have 2 roots. You know what? Let's say instead of this plus 6, I make this as plus 9. Where did it go? Oh my god, I think it's gone much on the top. Plus 6, I'll make it plus 7. Okay, see this. I made it just plus 7, guys. See, where did it go? I think you can very easily see over here. It is not even cutting the x-axis. So now, is it having any value which will satisfy? No. That means it has no root at all. I think you can make running notes, but the notes in RNA series is more than enough. The notes are very good. Yep. So that is the thing with quadratic equations. It can have 2 roots. It may have no roots. So how do I decide all these things? So let's come to the final formula for finding out the roots of a quadratic equation. For a quadratic equation, y is equal to some constant. It could be a, b, something, 2, minus 5, 100, 0.6, whatever, plus something into x, plus something into c. The roots, or basically the solutions, that is when y is equal to 0, are as follows. The first root is minus b, this one, plus root of b square minus 4ac divided by 2a, and the second root is minus b minus root b square minus 4ac whole thing divided by 2a. These are the 2 values, minus b plus or minus you can take. So once you take plus, second time you take minus, root b square minus 4ac divided by 2a. The graph of y versus x is a parabola. is a parabola, and this parabola, the nature of it depends on all these constants A, B, C. How curved is it? Is it expanded? Is it narrow? Is it up? Is it bottom? Is it intersecting, etc.? Depends on all these things. If at all you see that A is positive, then it is an upward parabola. It is an upward parabola. And if A is basically negative, then it is downward parabola. Then it is downward parabola. Let's put it to a test so that you guys can also see it. See over here, x square's coefficient, because that is what you have to see. A is the coefficient, it is with x square, correct? So can you see it is 1 over here and it is positive, so it is looking like a U-shaped parabola. Just make this guy negative and you will see immediately it will become inverted U-shaped parabola. Yes, inverted U, downward parabola. So whenever it is negative, you can put -4 or you can make this anything, doesn't matter guys. Even if this is plus 6x, I don't know, I'm just putting some random values. You can see it is inverted parabola, a downward parabola, but the moment you make this negative sign positive, it becomes an upward parabola. That is the coefficient of the square term that you should keep in mind. Correct. Next important thing, my dear students, that you should keep in mind is this constant decides whether the graph will pass through origin or not. If C is 0, then it passes through the origin. Then it passes through the origin. Else it will not pass through the origin. We can see that very easily over here. As you can see this right now, say for example, I just put it like this. The graph is definitely not passing through the origin because the constant term is 7. If I remove this and see how the graph will look like, yep, without the constant term, the graph is definitely passing through the origin. The graph is definitely passing through the origin, as you can see over here. Okay, clear, my dear students? Everyone till this point? All right. So these are some critical points to start off with quadratic equations. But it just doesn't end there. How do I know whether the roots are going to be positive, whether the roots are going to be 2 in number or not there at all? So that comes by looking at this term which is there inside the symbol root, square root. Inside that symbol, square root. What is the term? B square minus 4ac. I hope you know that root of a negative number is not real. That means if b square minus 4ac is negative, think about it, inside the square root you will have a root of -2. Root of -4, root of -16 is not 4. It is not even a real number. It is imaginary number. So then there are no roots for such an equation. So the graphs might look something like this. The graphs might look probably something like this. It will either go from the top or it could go from the bottom, but there is no intersection with the x-axis. It does not cut through the x-axis. I hope this is absolutely clear why negative root will not exist. That means you will not have any kind of root over here, real root, no solution in such cases. Second possible scenario, because the root of a positive number is a real value. Now there are multiple cases, we'll come to that, but if you generally have a positive value, let's say b square minus this term is basically a positive number, then there are two roots available, two solutions, two values of x that you will get. So that means our graph which is there, it will intersect the x-axis 2 times, once here, once here. either like this or like this, it will hit it or intersect it 2 times. And the last possibility is over here. What if you have root of 0? Root of 0 is 0. Root of 0 is 0. So just imagine if you have 0 inside, minus b plus 0 is minus b. Minus b minus 0 is also minus b. So the numerator denominator will be same. If inside terms are 0, that means both these values will be identical. That means it does not have two roots. So if by chance b square minus 4ac is 0, then it has a single root. Then it has basically a single root, and in such cases the graph might probably look something like this. It just touches it at a point. It just touches it at a point. No two roots, a single root. Is this now clear, my dear students? Everyone till this point? Absolutely? Very good, very good. Awesomeness, awesomeness. Let's solve some questions. Let's solve some questions, my dear students. Say for example, I tell you the quadratic equation that you have is 2x square and then plus 4x, or let's say plus 8x plus 2. Okay, this is your quadratic equation. The question is find the roots. Question is find the roots. Before finding the roots, there is one check which you should always do and see what is the term b square minus 4ac. What is the term b square minus 4ac actually called? This term which you see, b square minus 4ac, b square minus 4ac, that is called as the discriminant. Discriminant. Yes, that is called as the discriminant. So let's see what that discriminant is going to be. So b square minus 4ac, b is the coefficient of x, which is 8, square, minus 4 multiplied by a is basically 2, c is basically 2, so this is going to be 64, minus 2 2s are 4, 4 4s are 16, this is just going to be 48, which is more than 0, so that means it will have two roots. That means it will have basically two roots. So what are those two roots, x1 and 2? What are those two values? Minus b, plus and minus, root b square minus 4ac, whole thing divided by 2a. Okay, what is b? b is basically 8, plus or minus root of this guy came out to be just the number 48, divided by 2 into a. What is a? It is just basically 2. Yup, you heard it right. So this will just become minus 8 plus minus root of 48. 48 you can write it as 4 into 12. 12 also you can write it as 4 into 3, or you can just basically write it as 16 multiplied by 3. So root of 16 is 4. You will have root 3 over here. 2 2s are 4. 8 by 4 is nothing but 2, and 4 by 4 is 1, so you will have root 3. So the answers are as follows. The roots are, what are the roots? One is minus 2 plus root 3, and the second root is minus 2 minus root 3. So these are the two values for which this equation will become 0. That is the solution for it. Is this absolutely clear, everyone? Yep. Awesomeness, awesomeness. Very good. Keep it up. Awesomeness. Shall we move ahead to the next question? Shall we move ahead to the next question coming up on your screen? And here it is. If y is equal to, okay, y is equal to x square minus 4x, or let's say minus 6x, okay, minus 6x plus 9, what are the roots of the equation, and what that is what you have to figure out. So starting off with b square minus 4ac. What is b square minus 4ac over here? b is minus 6, square it, minus 4 into a is basically 1, c is basically 9. So what will I get? 6 square is 36, minus 9 fours are also 36. Best part, answer is 0. That means it has a single root. It has basically a single root. Oh, so what is that single root? x1 and 2, both the roots, minus b plus minus root. This will be 0 by 2a. Yep, this is 0, b square minus 4ac. So minus of b is basically minus 6 by 2a. A is basically coefficient of the square term, which is 1. Okay, minus minus becomes plus, 6 by 2, which means it is 3. So x equals to 3 is the root or the solution. I hope this is absolutely clear, my dear students. Yeah. So this is how essentially you solve the problems for, quadratic equations. Sir, is there a better way instead of using the formula? Answer is yes. If you don't like this formula, sometimes when the answers for the roots are not very weird, but they are nice numbers like 5, 6, 7, 8, 9, 1, minus 1, then here is the trick that you can use. It is called as the factorization trick. Factorization trick. So say for example, you have the quadratic equation x square minus 5x plus 6. Think whatever is the constant, the product of the roots should be 6. The product of the roots should be 6. And this, provided this is 1, okay, this will only work if this is basically 1, okay, and the sum should be basically minus 5. The sum should be minus 5. So what are those two numbers whose sum is minus 5 and product is positive 6? I can think 2 into 3 is 6, but 2 plus 3 is positive 5. But minus 2 into minus 3? Yes. Minus 2 into minus 3 is basically plus 6, and minus 2 plus minus 3 is minus 5. Oh, so what are the roots, my dear warriors? So basically the roots are, so what are the roots, my dear warriors? Yep. What are the roots, my dear students? Yep, come on, what are the roots? The roots are exactly in front of you. The roots are exactly in front of you. So basically what will happen is x minus 2 and x minus 3, okay, will be equal to 0. That is what is going to happen. That means whatever values you get over here, if it is negative, just make it positive. The roots are 2 and 3. That is what you will write. If it is positive, make it negative. If it is negative, make it positive. That's what you are going to make. That is the trick. So sometimes it will work, but majority of the times it will not work. So that is why it's okay not to remember this trick, because there are some conditions. This should be 1, it should be perfect integers, and then you have to change the signs and all of that. So it's okay even if you don't remember the trick. Mainly you should remember this particular formula which I have just shown you over here. Okay, mainly you should remember this particular formula. So that's about quadratic equations. Quadratic equations come at many places in your physics. For example, the displacement is 5t minus, let's say, 6t square plus 4. And the question says, when is displacement 0? If such a question is asked, you have to think in terms of whatever theory your Captain Shreyas Sir has taught you. Oh, this is a quadratic equation. What is that quadratic equation? I will write it in a beautiful form. The beautiful form will be, first put square minus 6t square, then put t, so 5t, and lastly the constant term. This should be 0. That means you have to find the roots. Basically you have to find the roots of the equation, the solution. So start with b square minus 4ac. b square minus 4ac, guys. b is over here 5. 4 into a is basically minus 6 into c is basically 4. So this is 25 plus minus is plus. 4 4s are 16. 16 into 6 is basically 96. 96 plus 25 is nothing but 121. Is that right? 96 plus 25 is 121. Now this number is definitely positive, so definitely it has two roots. Definitely it has two roots. So what are those two roots? The first root and the second root. Minus b plus minus root of that thing by 2a. That thing is b square minus 4ac. What is b over here? B over here is 5 plus minus root of, what is this? It is 121 divided by 2 into a. What is a? A is basically negative 6. So 121 is a perfect square, so it will be 11. 6 2s are 12, so minus 12. So there are two values that you get, minus 5 plus 11 divided by minus 12 and minus 5 minus 11 divided by negative 12. If you use this, 11 minus 5 is just going to be 6. 6 by negative 12. And the second value, minus 5 minus 11, that's going to be minus 16 by minus 12. So the answers are minus 1 by 2 and this minus minus will cancel. 16 goes with 4 4 times, 12 goes with 4 3 times. So negative 1 by 2 and 4 by 3. These are the two values. Is this clear? Everybody with me? Understood? Shall we go ahead to the next one? Shall we go ahead to the next one? Awesome, awesome. Great. Great. Okay. So after this, let's study binomial. Let us basically study binomial approximation. That is the next point that you should know regarding basic maths. That is what we are going to do next. Yes, binomial expression, binomial approximation. Now what is this binomial approximation? It's a tool, basically it's a tool or basically a formula to easen out the calculations, to make the calculations a little bit easy, to make the calculations a little bit easy. Oh, how, sir? I will tell you. First of all, let's understand what is a binomial expansion formula and then let's see how we can use it. The formula goes as follows: 1 plus x whole thing raised to n. N could be anything, but x must be very, very small or just small in general. Then this is approximately 1 plus, if this is minus also it works. If this is minus, then this will be minus. That n will come over here, that x will come over here as it is. That's it. That is your binomial approximation formula, and the condition for that is x must be very, very small. That's all. I will be like, okay sir, how is this going to help us? I will show you many applications. So observe this carefully now. Imagine there is a question, or while solving some question, you get some number like this: 1.03 whole raised to 4. Now, if you have to calculate this, normally you will have to multiply 103 with 103, then multiply that result again with 103 and that result again with 103. Don't you think it is very, very lengthy? That is definitely very, very lengthy. I don't want such a lengthy process. I don't definitely want such a lengthy process. Instead, what I will do, observe carefully. This, I will try to fit it in this formula. You'll be like, how come, sir? 1 plus a small number raised to n. 1 plus, yes, I can see that. It is 1 plus 0.03 whole thing raised to 4. Oh, isn't 0.03 very small as compared to 1? Yes, it is very, very small as compared to 1. So, thumbs up for using this formula. X must be very, very small. I can use this 1 plus nx. 1 plus n is 4. X is 0.03. So, this will become nothing but 1 plus 4 3s are 12. So, 0.12. So, the answer will be 1.12. That is the answer. So easy, isn't it? It becomes so easy, the calculations. Otherwise, it would have been tough. Like, sir, can you show me more examples? Why not? Observe the next example. Imagine 0.98's root. 0.98's root. We want to calculate this. Now you'll be like, okay, sir, this is the root and all. It looks a little bit awkward. Don't get scared. Just write it 1 plus x or minus x raised to some power. I think we can do that. This is actually 1 minus 0.02. Check this out. 0.98 is 1 minus 0.02. And what is root? Root is to the power half. Oh, sir, now it is understood, sir. Very simple. 1 minus x raised to n is 1 minus n. N is basically half x, which is 0.02. So this will be 1 minus 0.01, which is 0.99. Job done. So easily we calculated it. So otherwise we'll be stuck. How to calculate this root of 0.98, which is such a weird number? But the story just doesn't end there. Imagine we have to do this. Imagine we have to do this. 1 divided by 0.995 whole raised to 3. You will be like, okay, is this also binomial? The answer to that is yes. You will be like, sir, how exactly? See, what I will do, this is below, right? For binomial, everything should be on the top, right? So bring it on the top. Sir, how do I bring it on the top? Straightforward, just write it as a negative power. Oh, now it looks doable. 0.995, very close to 1. Somehow the value should be close to 1. So now it becomes 1 minus 0.005. Yes, 0.995 is 1 minus 0.005. Correct? And the whole thing raised to negative 3. Oh, now this is binomial form, 1 minus x raised to n. So answer will be 1 minus n. N is basically negative 3. X is basically 0.005. Negative becomes positive. 3 into 5, 15. So 0.015, which will be 1.015. So that's how we calculated this complex calculation and made it look simple. Is this right, everyone? Straightforward? Loving it? So nice, right? Oh, sir, can you give one more tough example? Okay, I'll give you one tough example on this and then we can move to the next topic, sir. See this, observe this carefully. Root of 65, or let's say we have to find root of 102. Now you will be like, sir, root of 102, sir? Sir, 102, I can't write 1 plus 101 because 101 is very large. Oh yeah, right, correct. We have to write 1 plus minus something which is very small. So there is a trick in this. What you do, first write it as 100 plus 2 whole thing raised to half, because square root means power is half. Now do the rest of the calculations. How? Whatever is this big number, right? Take it outside. Take it outside the bracket. So it will become 100 raised to half. 100 because I have taken it outside, 1 is left. 2 did not have 100, so I have to divide it by 100. And the whole thing raised to half. Did you understand this step? I've just taken this 100 outside and because 2 did not have it, I will have to put it in below. Oh, now what, sir? This is nothing but root 100. This is nothing but 1 plus 0.02 whole thing raised to half. Root of 100 is 10. This is 1 plus x raised to n. This is very small. So that's why I always take the big number outside. Then it looks solvable and it fits in the binomial approximation form. Yep. Yes, Veera, I'll be a part of the batch as well along with Shivan sir for physics. Yes. 1 plus n is half, x is basically 0.02. Oh, so this will be 10 into 1 plus 0.01, which is 10 multiplied by 1.01, which is 10.1. So square root 102 is 10.1. That's the answer. We got it. Done, dusted. Such an amazing question. Now, are you able to understand it, my dear warriors? Is it clear? Okay, how to use binomial approximation? Okay, so this is useful for calculation. Nobody will give you a direct question in the NEET exam. If you ask me, sir, was this asked previous yearly? I will be like, no, obviously it was never asked, because it will be a part of the calculation. Nobody will give you a direct question. These are tools. The next thing also which I am going to teach you is never going to be asked directly. It will be a part of the problem, just like quadratic. They will give you a quadratic equation. They will not ask you find the solution. It will be a part of the problem. Understand that. That's why the chapter name is called Basic Maths. You will not find it in NCERT. It is taught in the coaching only. Okay. So the next part is basically your series. Sometimes you have to add many terms, and then when you have to add many terms, you can't manually sit and add them. Rather, there is an easier formula for doing so. Now there are many kind of series, but in NEET perspective, you just need to know two kind of series. The two kind of series which you should know for NEET are, first is arithmetic series, or basically AP series, and the next one is called geometric series or geometric progression. Often the short form is GP. So geometric and AP. All right. So geometric, GP, and arithmetic, AP, arithmetic progression, AP. These are the two series. Now, what are these two kinds of series going to look like? I'll show you examples. Immediately you will get an idea. Look at this. AP series, 5. Then the next number that you add to it is 7. Next number 9, next number 11, and so on and so forth. Or example, let's say 90 plus 85 plus 80 plus 75, like this. Or let's say 5.2 plus 5.5 plus 5.8 plus 6.1 plus 6.4 plus. What do you see in all these numbers which is in common? What is one trend which is common? If you see 7 and 5, the difference between them 2. 9 and 7 difference is 2. 11 and 9 difference is 2. Here difference is 5. Here the difference is 0.3, 0.3, 0.3, 0.3. So as you can see in all these examples, the difference between them, the difference between the successive numbers is basically going to be a constant. If you subtract the two adjacent numbers, the difference will be basically a constant. This is often called as the common difference. Common difference between the numbers is same. Such a series is called as AP series or arithmetic progression. Cool? Yes, that is what it is. Now when you have to add such numbers, whenever you have to add such numbers, very simple. Say the first number is A, then the next number is A plus D, then the next number is A plus 2D like that. Then the last number, whatever is there, see this is the first, as you can see this is the first number, this is the second number, this is the third number, this is basically, let's say, your nth number. Whenever you have second number, the number with D is 1. Third number, the number with D is 2. Fourth number, the number with D will be 3. When you have the nth number, it will be A plus n minus 1 into D. And we want to add all of them. So I will put plus, plus, plus like that till the nth term. The answer to this, anybody who wants to tell me what the answer will be? Very simple to remember. It is actually the first term plus the nth term, the whole thing divided by 2, multiplied by n, First plus the last term, and just 1 second, let me drink some water. Thaya, like I mentioned, the syllabus will be completed by March. Yep. Priority will be given to 12th syllabus first, along with some essential concepts of 11th, and then the 11th. Yeah, that's how it will go. Yeah, so first term plus last term divided by 2, which means it will be into n. So a plus n minus 1 into D, whole thing divided by 2, the whole thing into n, which will be nothing but 2a plus n minus 1 into D, whole thing divided by 2, the whole thing multiplied by n. That is the answer. Either you can remember first plus nth term by 2 into n, or this formula 2a plus n minus 1 D by 2 into n. Either one will help you. I'll give you some examples so that you can understand it. Say I want to find 3 plus 6 plus 9 like that till, let's say, 10 terms. What will the answer be? First of all, I don't know what the last term is, but I know for the 10 terms I want to find the answer. So directly use this formula, 2a plus n minus 1d by 2. Here, this is basically a. The gap between both the numbers, the difference is basically 3. So d is also going to be 3. First term is also 3. The number of terms is 10, so n is 10. So using the formula 2a plus n minus 1d divided by 2 multiplied by n, 2 into a is basically 3, plus n is 3 again, sorry, n is, 10, minus 1, d is 3, whole thing divided by 2 multiplied by terms, which is 10. 2 3s are 6, plus 10 minus 1, 9, 9 3s are 27, whole thing divided by 2 multiplied by 10. So 2 goes with 10 5 times. Okay, 6 plus 27, guys, that's going to be 33. 33 multiplied by 5. Now 33 multiplied by 5, how much is it going to be? 330 divided by 2, which is nothing but 165, isn't it? Yes, 165. So 165 should be the answer. So very easily we can get it. Yes, that's the reason why we planned it that way, that we wanted 12th standard students also to be a part of it, and partial droppers also should benefit by the classes in the evening. Yeah, the books are compulsory in the pro batch. Yep, the books are compulsory in the pro batch. Otherwise, you have to go for the combo batch. But again, in the combo batch, few things are not there. You should go with the books because you will get additional material. Why would you want to lose out on that material? Cool. I will give you one more example so that you are understanding it completely. Nothing will be left out then. So let's say another example. You have let's say 5 plus 5 point maybe 5 plus 6 plus like that. Okay, you have some terms, all right, and let's say the last term over here is till maybe, I don't know, maybe 20 terms. 20 terms you have to take. 20 terms you have to take. Okay, so how do you do this? Here the first term A is 5. The gap between any two is 0.5. The number of terms is basically 20. So this is basically your n. So using the same formula again, 2a plus n minus 1d by 2. I'll put it 2a plus n minus 1d whole thing divided by 2 multiplied by n. A is nothing but 5 plus n is nothing but 20. D is nothing but 0.5. Whole thing divided by 2 multiplied by n. N is nothing but 20. 2 goes with 20 10 times. 2 5s are 10 plus 20 minus 1 is 19. 19 into 5 is 95. So it will be nothing but 9.5 whole thing multiplied by 10, of course. 10 plus 9.5 is 19.5. 19.5 into 10 is nothing but 195. So the answer to this particular question is 195. Yes, very good. Very good. Keep it up, my dear students. Very good. Now that you have understood what AP series is all about, let's go to the next one, which is GP series. I will give you an example. You will immediately understand what GP series is. See, I'll give you some examples. Let's say 20. Then the next term is 200. Next term is 2000 and so on and so forth. Or let's say 0.5 plus 0.05 plus 0.005 and so on and so forth. Or let's say 4 plus 12 plus 36. Okay, these numbers. Now you'll be like, sir, what is so special in all these things? 20, if you multiply it by 10, the difference is not constant. If you multiply it by 10, you will get 200. 200, if you multiply it by 10, you will get 2000. Next will be 20,000. Similarly, 0.5, you multiply it by 0.1, you will get 0.05. You multiply this by 0.01, you will get 0.05 and so on and so forth. Here, multiply 4 with 3, you will get 12. You multiply 12 with 3, you will get 36 and so on and so forth. So you are multiplying with the same number again and again. This number with which you multiply is often called as common ratio. Common ratio, the symbol for that is basically R. The symbol for that is basically R, and this is your first term, which is basically A. So these are your first terms, and the ratio with which you multiply, that is basically R. Oh, all right, all right. Right now, what is the formula for this? Observe. A next number AR, next number AR into R, so AR square. Next number AR cube. This is your first number, this is your second number, this is your third term, this is your fourth term. Notice for second the power of r is 1, third the power of r is 2, fourth the power of r is 3. So similarly for the nth, the power of r will be n minus 1. So it will be a r raised to n minus 1. Now if you add all these, the sum will come out to be a into r raised to n minus 1 whole thing divided by r minus 1. This is the formula. This is the formula. Now, no, trigonometry is not a part of this session because trigonometry in itself is a very huge thing. If you want trigonometry class, I have taken a trigonometry class long time back on this channel only. You can just go back over here and just search for trigonometry. You will get it. Yes, basic maths, algebra, trigonometry. Yeah, so I have done it right over here. Okay, not this one. I think you'll have to search for again basic maths only. So you will get it if you just search for basic maths also. I think if you search for basic maths, this was algebra class. Similarly, you will see trigonometry and geometry was done over here. So you can just search for it on the channel itself. Okay, cool. Now, this is generally not the so useful formula. The more useful formula is when you have infinite terms, very, very important. Infinite terms, very, very important, for sum of infinite terms with a very critical part, r less than 1. If r is more than 1, then there is no point. But only when r is less than 1. Like you can see, here r is 3, which is more than 1. Here r is 10, which is more than 1. So you cannot use that formula which I am going to give you here or here, but here it is applicable because r is less than 1. So only when the sum is still infinity and r is less than 1, then the formula becomes as follows. So a plus ar plus ar square, like that, infinite terms. The answer for that is just, if you add all of them, if you just add all of them, infinite terms, the answer is a upon r, 1 minus r. That's it. A upon 1 minus r. That's all. Not r minus 1, because r is less than 1, it will become negative answer. So 1 minus r, because r is smaller. So from 1 you will subtract r. So that is the answer to that. Let's have a look at some questions. Let's have a look at some questions. Imagine you had to do this only. Say for example, 2 plus 6 plus, like that. 18, like that. Let's say 10 terms. Let's say 10 terms. So what will be the answer be? First of all, this is a GP progression because you are multiplying it by 3 to get 6. You are multiplying it by 3 to get 18. So the number 3 becomes your common ratio. This is the first term, a. Number of terms is 10. This will be equal to, what is the formula which I just told you? It is a r raised to n minus 1 upon excuse me. Yeah, upon r minus 1. What is a over here? 2. R is basically 3 raised to n, that is raised to 10 minus 1, whole thing upon 3 minus 1. 3 minus 1 is 2, 2 will cancel, so 3 raised to 10 minus 1. That's it. You can leave the answer like this. You don't have to sit and calculate, sir, what is 3 raised to 10? Just leave it like that. Options also will be in that form. Another example which I can give you is something like this. Say you have a resistor, then another resistor, and like that there are infinite resistors. First resistor value is 20, next resistance value is 2, next resistance's value is 0.2, and so on and so forth. So what is the equivalent resistance is the question. Now if you see, this is a geometric progression where first term is A, you are multiplying the next number with 0.1, next number with 0.1, and that means common ratio is 0.1, which is less than 1, less than 1, and this is sum till infinity to find the equivalent resistance. Oh, so if you have to find the sum till infinity, it is just A upon 1 minus R. First term 20, 1 minus R, R is nothing but 0.1, so it will be 20 by 0.9, which is 20 by 9 by 10, which is 200 by 9 ohms. That is the answer. The answer to this is 200 by 9 ohms. I hope this is absolutely clear. Yeah. BA Kasirajan, if you are new to my videos first time, can you please tell me, will I see your NCERT line by line video of basic math? No, there is no NCERT line by line for basic maths, because in NCERT there is no chapter only called basic maths. It's a special chapter. NCERT things students will learn. How? God only knows. So they think that they will take maths or some coaching will train them, or God will only come and teach them, or some teacher like Shreyas Sir will teach for free on YouTube. Okay. I hope this is absolutely clear. Okay. So this is how you can use sum to infinity or sum of some terms in geometric progression. You will see such kind of problems even in gravitation, electromagnetism, where some masses or some charges will be given at some places. You have to find the potential and it will form a GP or it will form an AP, some or the other kind of arrangement. So in lot of chapters they will use this concept. Nobody will give you as a dedicated question. Correct. Very good. Now let's go ahead. Before we go ahead, just one small important thing which you should know, and that is basically called as logarithm. So you will see things like log of x to the base b, and that answer will be, I don't know, something like y. If you see such a thing, the answer for log of some number to some base is y. What it means is b, base, this is called as base. Base should be raised to the number y to get this particular x. That is the meaning of this word log, which is also called as logarithm. Logarithm, and it is useful in many places. Just giving you a quick update. Some of you might already have seen it in chemistry for especially the pH calculations and all of that. So just to see whether you have understood this or not, if I tell you what is the logarithm of 100 to the base 10, you should think like this. You should think like this. This number 10 should be raised to which number to get this particular number 100. The number 10 should be raised to which number to get 100? 10 raised to 2 is 100. So the answer to that is basically 2. Similarly, if I tell log of 8 to the base 2 is how much? 2 should be raised to which number to get the number 8? Obviously, the answer will be 3. 2 raised to 3 is basically 8. Similarly, if I tell you log of 1 to the base 15 is how much? Now don't even think too much. Any number raised to 0 is 1. So you have to think 15 raised to which number will give me 1. That number will obviously be 0. So log of 1 will always be 0. Log of 1 will always be 0. I hope this is absolutely clear. So this is the term logarithm. Now usually in physics and mathematics, the log that you use is ln. It is not log to the base 10. Usually you will see this term ln x. It actually means it's a short form of log of x to the base e, where e is your 2.7, also called as the Euler constant. This is also called as natural logarithm. Natural logarithm. This is called as Euler constant, which is 2.7 roughly. So whenever the base is e, if you don't want to write it like this, you can just write it as ln x. It is understood the base is e. It is understood the base is e. For example, ln e is the same as writing log of e to the base e. E should be raised to which number to get e? Obviously 1. E raised to 1 is basically e. If I ask you what is ln e cube, you will be like, it is same as writing log of e cube to the base e. E should be raised to which number to get you e raised to 3? Obviously the answer is 3. So that is how you will find ln of any number. Often very, very useful. SMK, you will have one more NCERT line by line series next week. Yes, definitely. Don't worry about it. Okay. Now let's go to the next part. Like we have seen series sum. This was done. Binomial approximation done. Quadratic expressions done. Now let's start seeing slopes, derivatives, and then we'll go to integration also. You will see both of them have very similar looking formulas. So if you understand one, you will also understand the next one. Are you ready for it? Show some josh, show some energy. Yes, SMK, that's the reason why we are conducting NCERT line by line series. Number 1. Number 2, that's the reason why NEET Express Station 1 is conducted in the evening, because we want 12th standard students to benefit from the live classes. That's why we are doing it, right? And during the board exam last year also we conducted classes. Same thing will happen this year also. Don't worry. Yeah. Question series will start from the first half of December. Before December 15, you will see something. Yeah, before December 15. I'll tell you why, when, how, everything. Next few days, okay? Cool. All right, let's go. Let's go. Now, what is this concept of slopes and derivatives? Imagine there is a Pandu and he is climbing up a stair like this. He is walking up a stair like this. Another Pandu, he climbs up a stair like this over here. Another Pandu, he is just walking horizontally on the ground. Here, I would say the slope of his motion is 0. He is neither going up nor going down. Slope is the steepness. Here, as compared to this, here the slope is less, meaning as he moves ahead, he is not going so much as compared to this. Here he is climbing up faster. So here the slope is more. That is the meaning of slope. Also, notice one more thing. If this Pandu is climbing up over here like this, the slope is said to be positive, and the same Pandu, if he is climbing down the stairs like this, yes, the slope is negative. Slope is negative. 0 slope, positive slope, negative slope. Less slope, more slope. And this slope is often used with the concept of rate of change. Slope, the slope of a graph, that is basically the steepness is often associated with the rate of change of a quantity, and often you will see it also gives sometimes the instantaneous values of a quantity. There are many examples of this. For example, the rate of change of momentum as per Newton is force. The instantaneous velocity is the rate of change of position. The instantaneous acceleration is the rate of change of velocity. Yes, the rate of change of angular momentum is torque. There are many such examples. Many such examples. That's where you will see the steepness or the slope of the graph comes into play. Now, imagine you have a graph like this. This is your I'm just going to turn off the AC, just 1 second. I don't think I can take the AC. And the graph is like this or like this, anything, it could be something like that. And I want to figure out what is the slope at some point. Let's say the point is over here. If you want to find how steep that graph is or how much the slope is, just like you can see in this particular example, you have to see how much you are going up as you are moving forward. So you just have to draw basically a tangent at this particular point. You just have to draw just a tangent at this particular point. That will be like a staircase. You know how much it is going up, how much it is going down. If my slope was less, then the tangent will be like this. If the slope is more, the tangent will be even more steeper. So a tangent drawn gives me a measure of how much the slope is. And all you have to do is from that tangent, see this particular angle which it makes with the x-axis. So I will just say the slope of the graph, is nothing but the slope of the tangent, and that is measured by nothing but tan of theta. That is nothing but measured by tan of theta. You find the theta, find the tan of it, and that's it. You will get the slope of that particular curve. That's it. That's how you can easily measure the slope, provided the graph is given to you. Now, say for example, the graph was actually given, and let's say this is x. The graph is like this. If I ask you, wherein all is the slope positive, then I ask you, wherein all is the slope negative, and then I ask you also, where and all is the slope 0. All you will do is think of drawing tangents. Yes, if you draw a tangent here, or even here, you can see the tangents are going up. Even when you draw a tangent here, or even if you draw a tangent here, the tangents are going up. But if you draw a tangent here, or let's say a tangent here, or let's say a tangent here, these tangents are going down. And if you draw a tangent here, it is going horizontally. Even this tangent is going horizontally. Even this tangent is going horizontally. So which means where and all is the slope positive? The answer is in this particular region, it is positive. And even from here till here, you can see that it is nothing but positive. Where and all is it negative? It's here where it is negative, and also over here where it is negative. Where and all is it 0? Means it's not going up nor going down. It's 0 here, it's 0 here, and also 0 over here. Is this now absolutely clear, everyone? Yep. No, errors is not a part of this lecture. Basic maths is a separate lecture from units and dimensions. Yeah. So 28, you know what? This is actually the most common problem, and that's why I said I'm going to start with something for problems, especially in physics. If you are facing problems with physics, then whatever I'm going to do next, obviously in station 1 as well as on YouTube, that is what is going to help you understand, apply, and also solve the PYQs. That part is coming. I know if you're understanding, you're good. If you're not understanding, then that was a reason for worry. But you're understanding, that is a good thing. You just need to put one more step, two more steps, and then you need to make it into a routine. That's it. You will get a hang of it. It's not very far from what toppers will achieve. Okay. Now, fine, if graph is given, I can find by tan theta, but usually graph is not given. Usually what will happen, they will give an equation. Like this graph over here might have an equation. So, if graph is not given or can't be found, instead y is some function of x is given, then the slope of y versus x, very very important what I'm writing, then the slope of y versus x is given by dy by dx, which is also called the derivative or differentiation, derivative or differentiation of y with respect to x is given by the derivative of y with respect to x. You can also write it as f dash of x. The dash on the top is not the power. It says that I have differentiated it. I have taken the derivative of it. That formula, that process will give me the direct slope. I'll be like, sir, what is this dy dx? Sir, I don't know. You don't even have to worry right now. See, that instantaneous concept and all that, you learn it in kinematics 1D. For now, just think that there is a magic box. For now, just think that somebody has given you one magic box. This magic box. Who gave you that magic box? One mathematician. One mathematician, long hair. Alright, this is a mathematician who has a wand, and that mathematician has given you this magic box, and he will ask you, you tell me that function, I will give you the answer of the derivative. You give me fx, I will give you the derivative. You tell me the function, I will tell you the derivative. So what is that magic box going to look like? It's just a set of formulas. For example, I will tell you, imagine over here I write down the functions, say for example x raised to n, or constant, or sine of x, or cos of x, or ln x, or e raised to x. I'll just use some more space. Yeah, this was constant. What else did I write? Sine of x, cos of x, ln x, e raised to x, some basic functions. Using that magic box, I will get the derivative, which is f dash of x. What is the derivative of x raised to n? The answer for that, nx raised to n minus 1. You don't have to worry where it came from. That's just what the mathematician gave it to you. It's a gift from the mathematician. Whenever you see x raised to n, the derivative is nx raised to n minus 1. If it is a constant, the derivative is 0, because constant means it is not going up nor going down, so the slope will be 0. Sine of x, the derivative is cos of x. Cos derivative is negative sine of x. Log of x, the derivative is 1 by x. E raised to x, the derivative is e raised to x only. The derivative is e raised to x only. So that's it. If you remember these formulas, you will be able to solve all the problems of NEET. In NEET, they don't ask you complex things like log of sec x plus tan x minus e raised to x. Nobody is going to bother like that. They also know you are PCB students. So most of the times this and this formula more than enough. Sometimes only these formulas come, very rare. Most of the times these formula is more than enough. Between ln and log, I think I just told you over here. ln is when the base is, it's a natural log. It's a natural log. When the base is basically e, then it is ln x. But when the base can be anything else apart from e, then you cannot write ln, you have to write log, log. When the base is specifically e, you can write it as a shorthand. You can skip writing the base and write it as ln x. Is that clear? So let's see the examples of this. Let's see the examples of this. Say derivative of x raised to 3 with respect to x. This looks to me like x raised to n is the function. I have to find the derivative of it. Oh, the answer should be nx raised to n minus 1. Correct. Here, this number 3 is basically n. So the answer to that will be n comes outside, and the power is reduced by 1, n minus 1. You can see that, n minus 1. So hence, the answer to that will be 3x square. Perfect. Let's go to the next example so that you understand it. Derivative of, let's say, x raised to 11. Now over here, what is n? N is basically 11. So that number 11 will come outside, multiplied by x raised to 11 minus 1, which is 10. So 11 x raised to 10. Perfect. Next example. Derivative of just x with respect to x. Easily you can cancel this and write it as 1, but I will not do that. I will show it to you with the formula. See, here you can write it as d x raised to 1 by dx. Don't ever cancel this d like this. Don't do that. That is not allowed. So here n is basically 1. So 1 comes outside and it will be dx raised to 1 minus 1 by dx. Yep. So what will this be? This is, oh sorry, why did I put like this? My bad. 1 comes outside, x raised to 1 minus 1. What will this be? 1 into x raised to 0. X raised to 0 is nothing but 1, so the answer is just 1. Anyways, by cancelling you will get that, but that is not the right way of doing it. Please understand that. That is not the right way of doing things. Okay, sir, this is very simple, sir. If I know the formulas, then my job is done. Yes, exactly. If you know the formulas, your job is perfectly done. Say, for example, you have been asked the derivative of root of x. You will be like, oh sir, this is scary now. Don't worry. Just write it as derivative of x raised to half. Oh, so n is basically half. So n comes outside, x raised to half minus 1. Half into x raised to half minus 1 is negative half, which I can write it as half divided by x raised to half. But we know what is x raised to half. It is the root of x. So I can write it as 1 by 2 root x. That is how you find the derivative of root x. Okay, sir. Now this is getting interesting. Sir, what about the derivative of 1 by x, sir? No issues. Because x is below, don't keep it below, always bring it on the top, because the formula which I know is x is in the numerator, nothing is below. Below it is 1. So that is something which you need to keep in mind. Okay, sir. So this will be derivative of x raised to negative 1. Oh, so n is basically minus 1. So n comes outside and x raised to minus 1 minus 1. That is what happens, n minus 1. So minus 1 into x raised to minus 2, which is minus 1 into x's negative power means x square, which is minus 1 by x square. That is the answer to it. Is that clear? Similarly, the derivative of 1 by x cube, what will this be? Don't get scared because it is below. You just have to bring it on the top, negative power. Oh, so n is basically minus 3. So n comes outside and the excess power you have to reduce it by 1. So minus 3 into x raised to minus 4, which is minus 3 into negative power means I have to bring it down. So this will be minus 3 by x raised to 4. That's how you solve this, guys. Got it now, everyone? Okay, too good. Okay, sir, I'm getting a hang of it. Are there more formulas in this? Yeah, there are some basic formulas for addition, multiplication, division, subtraction and all that. I will just tell it to you. First of all, if you have to ever find the derivative with some constant multiplied by that function, just take that constant outside and then take the derivative. Just take that constant outside and then take the derivative. That is the first rule which you should know. Okay, if there is a constant. Next rule, if you have to find the derivative of a function f plus g, one function plus another function or one function minus another function, just find the derivatives individually. Just find the derivatives individually and then do plus and minus. That's it. Next, there is a rule for even multiplication, f multiplied by g. All you do is write the first function, write the second function, put a plus symbol. Now take the derivative of the second function in the first term, and here take the derivative second function in the first term, and here derivative of the first term in the second term. F derivative of g, g derivative of f. That's what happens when you have to multiply. Lastly, when you have to divide, that is f by g, then here is what you will do. You will first put g, the denominator, into derivative of the numerator minus first function into derivative of the denominator, and the whole thing divided by denominator square. Whole thing divided by denominator square. So this is multiplying by constant, this is addition, subtraction, this is multiplication, this is division. Now I know you will be like, sir, I didn't understand anything. Can you please tell me how to solve the problems? That will be more helpful. Yes, don't worry. So let's do some questions. Say you have to find the derivative of sine of x plus cos, forget sine of x plus cos of x, just the derivative of 4 sine of x. As you can see, this is the first rule which we are using, constant into function. That constant, bring it outside. It will be 4 times derivative of sine of x. What is the derivative of sine of x? I just told it to you over here. It is nothing but cos of x. That's it. So just write over here So just write over here 4 multiplied by cos of x. That is the answer, my dear warriors. Let's say you have to do this derivative of minus cos x. This negative will just come outside, so it will be derivative of just cos of x with respect to x. Yes, this minus will come outside. And what is the derivative of cos? It is negative sin x. Minus minus will become plus, so the answer will be positive sin of x. The answer will be positive sin of x. Yep. Awesome, awesome. Now, sir, what if there is addition? Okay. Derivative of e raised to x plus sin of x. What did I tell you? When there is addition, take the separate derivatives and then add them. Separate. This is one function, this is another function. So just take derivative of e raised to x, take the derivative of sin of x and just add them. That's all. Derivative of e raised to x is e raised to x. Derivative of sin of x is just cos of x. Job is done. Similarly, if you have to find the derivative of, let's say, ln x minus x square. This is negative. Even if it is negative, don't worry, take the separate derivatives and then subtract them. So it will be just the derivative of ln x, that is log x to the base e, minus derivative of x square to the base x. Derivative of ln x, if you have forgotten, remind you, it is 1 by x. Yep. Okay, it is 1 by x. So coming back over here, yep, it is 1 by x and x raised to n, this is n guys. So 2 into x raised to 2 minus 1. So 1 by x minus, this will be 2 times of x. 2 minus 1 is 1, so 2x. 1 by x minus 2x is the answer. So this was constant, this was addition, this was subtraction. Very simple. Let's go to multiplication and division. Shall we go to multiplication and division? Okay, let's go to multiplication and division, guys. Okay, so let's say an example of multiplication. Derivative of ln x into x square. Two things multiplied. There is no plus or minus. Instead of minus, I have put multiplication. First, write the first function. Leave some space. Write the second function. Now, put the derivative of the other guy, that is this guy, and put the derivative of this guy over here. D by dx of ln x. Your job is done. So this will be ln x, derivative of x square. Here n is basically 2. Here n is basically 2. So it will just nothing but be 2 into x raised to 2 minus 1 plus x raised to 2. Derivative of ln x is 1 by x. Okay. So ln x, okay, so I can just write it as 2x ln x. X raised to 2 minus 1 is basically 1. So it is 2x into ln x plus this will cancel and this will be x. So this is the answer. If you want, you can write it as x into 2 ln x plus 1 also. That is the simplest way you can write this. That's how you use the multiplication rule. I'll give you one more example. Derivative of sine of x into, let's say, e raised to x. What do you do? First put sine of x, leave some space, put e raised to x. Now put derivative of e raised to x and here put derivative of sine of x. This will be sine of x. E raised to x's derivative is e raised to x. Derivative of sine of x is cos of x. So you can take e raised to x common and the answer will be sine of x plus cos of x in the bracket. That's how you do for multiplication. Cool? Understood? Let's do the next one. Let's do the next one. Let's say I want to find the derivative of tan of x. Now you will be like, sir, how do I find the derivative of tan of x? Well, tan is nothing but sine by cos. Oh, division. And what is the rule for division? Denominator derivative numerator minus numerator derivative of denominator by denominator square. That is the formula. So just do this process. denominator cos of x, derivative of numerator, which is derivative of sine of x, minus numerator, which is sine of x, derivative of denominator, which is cos of x, whole thing divided by denominator square. Okay, so what will this be? Cos of x into derivative of sine is again cos of x minus sine of x. Derivative of cos is negative sine x. Whole thing divided by cos square x. Okay, cos into cos is cos square x. Minus minus plus sine square x. Whole thing divided by cos square x. Wait a minute, this is an identity. Sine square theta plus cos square theta is always 1, no matter what that theta is, x, y, 5 degree, whatever. So this will be 1 divided by cos square x, hence this will be sec square x. So derivative of tan x is sec square x. That is how it has been derived. Cool? Clear? This is your division rule which is there in derivatives. So whenever you have been asked to find the slope, you are just going to use these derivative formulas and these rules of multiplication, division, etc. as it is. Just to give you one more example to find the slope. Example, they ask you, nobody will ask you, this will be a part of a problem. The slope of y is equal to 4x square at x is equal to, let's say, 3. That is what the problem says. Slope means derivative, dy by dx. But here, the value of y itself is 4x square. I can see 4 is a constant, bring it outside, and I am left with just x square. Here, n is basically 2. So, using the formula, it will be 2 into x raised to 2 minus 1. 4 2s are 8. So, this will be x at only. So, that is the slope of the y versus x. But there is a special question here at x equals to 3. So, the slope at x equals to 3 will be obtained by putting x as 3. So, put x as 3. So, the answer will be 24. That's how easily you can find the slope by just substituting the values in the end. That's all. That's how you just find the values. Just put the value of x. If they ask you in any of these questions, find the value of the slope at 30 degrees. So put x as 30. So sec 30, which is 1 by cos 30. Cos 30 is root 3 by 2. Square is 3 by 4. So it will be 4 by 3. That is the answer. So that's how you solve the questions. Another example. Find the slope at x equals to minus 1 for y is equal to x minus 1 by x plus 3. Looks like a much more lengthier problem, not difficult. First of all, slope is asked, that means derivative, dy by dx. Here, y is this big thing, 3 things are there. So you have to find the derivative separately, dx by dx minus d by dx of 1 by x plus d by dx of the number 3. Dx by dx, we have done this before, but if you still don't remember it, I will write it like this. Minus, put the power negative on the top, and this is a constant, the answer will be 0. This is a constant. Derivative of a constant is always going to be 0. Remember this, 1 into x raised to 1 minus 1 minus d by dx of this guy will be minus 1 into x raised to minus 1 minus 1. This is x raised to 0, which is 1, minus minus becomes plus, x raised to minus 2. So this will become 1 plus 1 by x square. That is what it is, but special value, the slope at x equals to negative 1 will be, put x as negative 1, 1 plus negative 1 whole square, So 1 plus 1 by 1, which is 1 plus 1, which is basically the number 2. That's how you get it. Okay, now J application is over. The time limit is gone for January attempt. You can try for the April attempt. Perfect. Sir, now I understood derivatives, sir. Clear? Shall we go with the integration concept, the basics of integration? Because then when the integration comes in center of mass, moment of inertia, or kinematics, or any other place, maybe electromagnetism, you will be able to remember the formula or the process. Then you will understand the concept why integration is used over there. Okay. Now, remember that magic box which I just told you about? Which was the derivatives magic box, right? This was the magic box. And here, if you have a function, if you give it in, what you get out is the derivative of this. So this is basically called the derivative of f of x. Imagine the April is the second attempt. There are 2 attempts in JEE. Advanced is in May. Once you clear mains, then you write advanced. Now imagine exact reverse question is asked. Somebody gives me a function and then asks me whose derivative is this. Mathematician will think, if you give me this, I give you that. If you give me this, I give you that. If you give me that, who does it belong to? Reverse calculation. Yep, you give me this, you tell me whose derivative it is. That is called as the integration. The integration of g of x, which is antiderivative, which is nothing but antiderivative. As simple as that. It's nothing but the antiderivative. And that is written down as, with this symbol, you use this symbol like this, integration of g of x dx. Integration of g of x dx. That is what integration is. It is exact opposite of derivatives. You have to think whose derivative is that. Whose derivative is that? Let me give you an example. Imagine I tell you, can you tell me what is the integration of e raised to x dx? You have to think whose derivative is e raised to x. E raised to x's derivative is e raised to x, so the integration will be e raised to x only. Integration will be e raised to x only. Is that right, everyone? Similarly, if I write integration of, let's say 1 by x dx, you will think whose derivative is 1 by x. Try to recollect all the formulas. There is only one formula whose derivative is 1 by x. Yep, it is ln x, log to the base e. That's how you get this, my dear warriors. There is a small catch. Tell me one thing. If I take the derivative of e raised to x, the answer is e raised to x. But derivative of e raised to x plus 3, well, that is derivative of e raised to x plus derivative of 3. 3 is a constant. So this will be still e raised to x plus 0, which is still e raised to x. So if there is a number in front, the answer is still the same. Which means, when I think the reverse, whose derivative is e raised to x? It could be e raised to x plus 3, e raised to x plus 5, e raised to x plus 10, e raised to x plus 100, because constant, if it is there, the derivative automatically becomes 0. So I would have no way of knowing whether there was a constant or not. Hence, to add that benefit of doubt, I put plus c, which is also called as the constant of integration. Constant of integration. It is like a benefit of doubt. I have not seen that person robbing someone, so I have to give it the benefit of the doubt. The person may be a robber, may not be a robber. Same way, I do not know whether the constant was there in the original function or not there. Another example over here only. If I just take the derivative of ln x plus 7, or let's say even minus 7 with respect to x, it will be derivative of ln x with respect to x minus derivative of 7 with respect to x. This is 1 by x minus 0, which is still 1 by x. Whose derivative is 1 by x? Ln x also, ln x minus 7, ln x plus 0.5, ln x plus 1000, doesn't matter. So, to give that benefit of the doubt, I have to add the constant of integration. Got it? Now, whenever that benefit of doubt is there, then remember, such type of integration is also called, because I do not know what is this, what is the value, I do not know, because I'm not sure, I'm not definite, so it is called as indefinite integration. Indefinite integration, because I'm not really sure what that constant is. I'm indefinite. Defined means I know it, indefinite means I do not know it. Yep, that's how it works. So integration, the symbol is like this. Like derivative is always with respect to dx, integration is also with respect to dx, but instead of division you multiply it. That's the reverse thing. That's why it is also called as anti-derivative. It is exact opposite of derivative. So with this we can directly start seeing the formulas for integration very easily, starting off with what might be the integration of dx. You'll be like, sir, what the hell this is? I'll tell you what. Integration of dx can be written down as integration of 1 into dx. Think whose derivative is 1. Immediately you will get the answer. Yes, whose derivative is 1, guys? Derivative of x with respect to x, dx by dx, 1, right? So the answer will be x, to add the benefit of the doubt, plus c. So the answer is basically for this, in general, x plus some unknown which I do not know. So that's why x is the answer. Correct. Similarly, if I ask you what is the derivative of, let's say, e raised to x, your answer will be e raised to x plus c. Integration of 1 by x dx, yep, it will be ln x plus c. What is the integration of x raised to n with respect to x? Here the formula is slightly different, opposite. Instead of reducing the power, you increase the power by 1 and divide it, not multiply, with that increased power. Remember, in derivatives you are putting n outside and reducing this n. Here you increase it and divide it by that increased power. That's what the answer will be, plus c. But here n should not be equal to 1 negative, because if n is negative 1, think about it, x raised to minus 1 will be 1 by x. Then you have to use this formula. So only when x is not equal to negative 1, you can use this. That is only one special value. Then you use this particular formula. Otherwise, every single time you can use it. Next one, derivative of sine of x dx. Lot of you will think it is cos x. Wrong. It is minus cos x plus c. Yes, minus cos x plus c, because cos's derivative is negative sine. So negative cos derivative is plus sine. So you have to think whose derivative is sine. It's not cos. Cos derivative is negative sine. So negative cos's derivative is negative, which will be positive sine. And in fact, derivative of cos of x will be positive sine x plus c, because derivative of sine x was cos x. You have to look at it like this. Derivative of sine x will be cos x. That's how the formulas go. Very straightforward. Let's take some examples so that you understand this. It is not that difficult. Imagine I tell you, you have to do this integration of x cube dx. As you can see over here, I will have to use this formula. N is 3. I am allowed to use it. So x raised to n, which is 3 plus 1 by 3 plus 1 plus c. So it is x raised to 4 by 4 plus c. That is the answer. Similarly, next example, integration of root of x dx. Well, this is integration of x raised to half dx. Okay, so here n is half, so x raised to half plus 1 by half plus 1 plus c. So half plus 1 is 3 by 2. So this is also 3 by 2 plus c. That is the answer for this. Another example, integration of 1 by x cube, or let's say 1 by x raised to 4 dx. It's below, always shift it on the top, negative power of 4 on the top dx. Here n is negative 4, so x raised to n plus 1, so minus 4 plus 1 by minus 4 plus 1 plus c. So it will be x raised to negative 3 by negative 3, which is negative x raised to minus 3 by 3 plus c is there, plus c is there. This is negative 1 by 3 x cube plus c. Negative power, I can bring it down as positive power. So that's how you basically integrate. That's how you basically integrate. I hope you guys got an idea of this. Now, in derivatives, there were many rules, but in integration, there are only 2 rules. You don't have multiplication and division. It's not a part of the syllabus. The only 2 rules which you need to know is whenever you have to integrate a constant with respect to that function, that constant can be brought outside and you can write it as integration of f of x dx. The constant can be brought outside. Okay, that is the first rule. The second rule is if you have to integrate 2 functions which are added or subtracted, all you can do is integrate each function separately and then you can add or subtract it. Then you can add or subtract it. Let me show you some examples so that you understand these rules. It's not that difficult, of course. Say I have to integrate 4 sine x dx. I just can bring that 4 outside and it will be just integration of sine x dx, which is 4, and the answer for sine x's integration is negative cos x plus c. So answer will be negative 4 cos of x plus c. That is the answer. Yep. Very good. Very good. Next question. Let's say you have to integrate e raised to x plus 1 by x dx. Since there is addition, you can separate out the integration. E raised to x is separate and 1 by x is integration separate. Integration of e raised to x is e raised to x. 1 by x special value, integration is log of x. Will I put c1 and c2? No, that will be foolishness. Just put one single constant, it is enough. Another example, let's say I have to integrate sine of x minus cos of x dx. Subtraction, so I can separate out the integrations. Sine of x's integration separately, cos x's integration also I will separate it out. Sine x's integration is negative cos of x. Cos x's integration is basically sine of x. Just put one constant, it is enough. Don't have to put 2 constants. Is this clear how to solve this, my dear students? Yep. Dhanushri, which session timing you are asking? Way optics, like I said, 𝐂𝐤 next week, NCERT line by line. That's the last session of NCERT line by line. Session timing of NEET Express 1.0, like I said, it starts from 5 o'clock, 6 o'clock in the evening times. Yep. So that all students can attend. Okay, sir. Understood this. Now, see, the last part is See, if you have f of x's integration with respect to d of x, and let's say the answer is something plus c, this type of integration is called indefinite integration, where this constant is unknown, you do not know it, you have a constant of integration. But there is another kind of integration where you will write things like this: integration of f of x dx L u. What is this L? Because it is below lower limit. This is on the top, so also called upper limit. The answer to that is the same thing, but first you put, instead of x, the upper limit, then instead of x you put the lower limit, subtract the 2. Yep, this type of integration is called definite integration. Definite integration. Yes, there are no constants in it. There are no constants in it. Please remember, this is not the same as g of u minus L. Don't subtract upper and lower and then substitute. Substitute, then subtract. What do I mean by this definite integration? Let's see an example for this. Let's see an example for this. You will get it. It's not that difficult. See, observe carefully. Imagine you had to integrate x square. And here you have 1, here you have, let's say, the number 2. Okay? First, integrate it normally, like how you would do. Forget the lower upper limits. Integration of x square. This 2 is basically like n, right? This 2 is basically like n. So it will be x raised to 2 plus 1 by 2 plus 1. Now, because the limits are there, I have to keep that in mind. I cannot forget about it. Just to carry it forward, I'll just put square brackets, put 1 and 2. This is just to symbolize that I am keeping in mind those limits, but integration part is over. So what is this going to be? X raised to 3 divided by 3, because I still have to remember it, 1 and 2, I'll keep it over here. Now what did I say? Once this is done, substitute upper limit, then lower limit, then subtract it. Put 2 first, so 2 cube by 3. Then put 1, so 1 cube by 3, and then subtract it without any constants of integration. So this will be 8 by 3 minus 1 by 3, which is 7 by 3. That is the answer. As you can see, the answer to a definite integration does not contain those constants. It will be a value. So normally how you do the integration, you will get something. Here, instead of that something, you have to put those limits 2 times and then subtract it. First the upper limit, then the lower limit. Let's do more questions on this so that you guys get an idea. Let's do more questions. Imagine you had to do integration of let's say e raised to x dx from 0 to 4. What will you do? Normally how you would integrate? Integration of e raised to x is just e raised to x. Because I have to keep in mind those limits, I will put square brackets and put the lower and the upper limits. First put the upper limit instead of x. Then put the lower limit instead of x. Subtract the 2. E raised to 4 minus e raised to 0. Anything raised to 0 is 1. So the answer is e raised to 4 minus 1. That's it. As simple as that. It's not very difficult, guys. Let's do one more example so that you guys get an idea. Say you have to do integration of sine of x dx from, let's say, pi by 6 to pi by 3. Pi by 6 to pi by 3. Now, what does this mean? Or let's say from pi by 6 to pi by 2. Some random values I have taken. First do the normal integration. How you would do normally? Sine x's integration, negative cos of x. Okay. Put square brackets, lower limit here pi by 6, upper limit here which is pi by 2. Okay. First put the upper limit, so minus cos pi by 2. Then put the lower limit, minus cos pi by 6. Then subtract the 2 minus. Cos of this is 90 degree. Cos 90 is 0. Okay. Minus pi by 6 means 30. Cos 30 is root 3 by 2. Okay. This is 0. Minus is plus. So the answer is root 3 by 2. Got it? How to do the definite integration? It's not difficult at all. Oh, this is interesting, sir. So then what is the use of this definite integration? Let me tell you that. It is useful in many places. You will most of the time see definite integration only. What will happen is you will have a graph. Graphically, this is y, this is 0, this is x. You will probably have some graph like this. And let us just say between this point here and this point here. Let's say this is L, this is U. X is equal to L, X is equal to U. You want to find what is the area under this particular graph. What is this area under this graph? That is given by the definite integration. So the area under y versus x graph is given by the definite integral of y from x equals to L to U as the limits, which means you just have to put integration of whatever that function is with respect to x, put the lower limit here and put the upper limit here. So the area under the graph is given by the definite integral from lower limit to upper limit. Those are the points between which you have to find the area. Oh, that's it, sir. But there is one small thing which you need to know. If at all the graph is on the top versus the graph is below, notice one small change. When you measure the area here, this area is considered positive area, and if you measure the graph here, area, this is considered negative area. So that also has to be kept in mind. So let's do an example maybe on this. Say the question says, listen, I have a graph like this. This is your y, this is x, this is 0, and I tell you the function goes like this: y is equal to x cube, and you have to find the area till here where x is equal to 2. You have to find the area till here where x is equal to 2. So how will you find the area? So as we know, the area under the graph will be the integration of that function from the lower limit to the upper limit. Whatever the graph is, that function I already know. What is that function? Well, that function is x cube. What is the lower limit? This. Upper limit, this. Lower limit is 0, 0, 2, x equals to 2. Oh, x cube integration, x raised to n, this is like n. So x raised to 3 plus 1 by 3 plus 1. This is definite, so no need of constant. Lower limit, upper limit as a reminder. Okay, integration part is done. So this will be x raised to 4 by 4, and this will be 0 and 2. First put 2, so 2 raised to 4 by 4. Then put 0, 0 raised to 4 by 4. So this will be 2 raised to 4, 2 cube is 8, 2 raised to 4 is 16. So 16 by 4 minus 0, which is just 4 units. So this area, which is a very weird area, is going to be 4 units. Job is done. Another interesting question on this, let me show it to you. Imagine you had to find the area under sine of x, or let's say the area under cos of x from 0 to pi radian. How much is that area going to be? As per the formula, this area will be integration of cos of x from 0 to pi. So 0 to pi. That is what it is. Definite integration of the function from those limits, the area under which it is bound. Okay, so I have formulated this integration. Now, integration of cos is just sine of x. I hope you remember this. In case you have forgotten, let me remind you. Integration of cos is positive sign. Derivative was negative sign. Okay, so this will be just sine of x. Integration part is done. No need of constant. Square brackets, to just remind myself, I have to put the limits. First put pi, upper limit. Then put lower limit. Then subtract. Pi is 180 degrees. Sine 180 is 0. Sine 0 is also 0. So the answer is 0. Wow. The answer is 0. Something has gone wrong? No, nothing has gone wrong. I'll tell you why also. Actually, if you draw the graph of cos of x versus x, this particular graph starts from 1, goes like this, goes like this, goes like this, and completes here. This is 360 degrees or 2 pi radian. Pi radian is actually over here. This part is pi by 2. So what happens is, when you measure the area from 0 to pi, this part of the area is positive and this part of the area is negative by convention. Hence, this part and this part being equal and symmetric, they will cancel. That's why the total area from 0 to pi is 0. That's how you get it. Got it, my dear students? Very good. So glad, Shruti, Blessy, it's crystal clear. So, if you see, we have seen the basics of slopes and derivatives, as well as the area part and the basics of integration for basic maths. This is useful now in many places. Wherever you see it, this lecture will help you at least know the fundamentals, the basics of integration, derivative, series, quadratic equation, logs, or even the binomial approximation. All these are calculative problems for use for calculations. Remember, nobody in the NEET exam will ever give you any question directly from any of these. It will be used in one of the problems. These are mathematical tools. These are, skill set which you should know. Cool. I hope this is clear. Graphs, I had conducted a special class long time back. You can see that Aranya. Yeah, you just have a look at it. Cool. But whatever I promised today, I have done that. Okay. So likewise, there is no end to basic maths. And if you are wondering, sir, if I want more detailed lecture of basic maths, more concepts, have you taught it somewhere? Yes, it's there in the NEET Express Station 1. You will find all the lectures, basic maths, taught right from algebra, trigonometry, geometry, and derivatives, integration separately, vectors separately, all of them. So you will find it there. So make use of those lectures. Okay. So thank you very much. Have a great time. I hope you enjoyed this lecture, and I will see you in the NEET Express batch. Now the link for the NEET Express batch is there in the description box of this particular video as you are watching it. This was station 0. The station 1, as you can see, continues on our platform, and all your favorite master teachers are there, and the batch prices are as low as 2,999 for 5 months, and all the features of live classes, in-class quizzes, leaderboards, discussions, practice questions, everything is there, along with DPPs, recordings, access to recorded videos in VBuddy, as well as you have the pedagogy assets where you can generate DPPs, tests, etc. All of that is there in all the 3 versions. Extra thing that you will get in the Prime combo is the test series. Some of you want the test series additionally. Apart from the online tests which we conduct, this is additional tests which will be given to you. That will be here in the Prime combo, and the Pro will additionally give you the 24/7 doubt solving along with the crash course books which will be delivered at your home place. Yeah, and this will also include the test series which will be delivered to you. All the links are there in the description box. Make sure you join now because the batch starts this Monday. Yes, you heard it right. 2nd December starts and the syllabus will be completed by March, and full syllabus test series in March itself it will start. So the revision will go on for more than 1 month. So you will have enough time to prepare and crack the NEET exam. This is the only kind of comprehensive program which is not a crash, but it is in detail, plus it is rigorous and enough amount of content with practice is given to you. So make sure you are a part of it, and it's in pure English, obviously with the best of the best teachers. We too will be involved, but don't expect I will take all the classes. Few classes only I'll be there, but nevertheless the reason is I'm already involved in many things, and you have the best teachers in the batch who is going to take care of you. Thank you so much. Have a great time. God bless you all. Hasta la vista.